Hello, and welcome to Training with Trisonius. I am Trisonius. Today we're going to focus on constants and literals. So how do we define unchanging variables and define literal values? Well, you already know how to define literal values. I just don't think you realize that that's what they're called. So let's go ahead and move forward. So what will we learn today? This is one of our smaller lessons, and it focuses on constants. It focuses on literals. Now there are two types of literals. There's numeric literals and there are text literals. So we're going to dive into both of those, and we'll see some code examples of those. Now it's important to note there is no homework assignment at the end of this lesson. This is really a return back to variables, and we're just going to expand upon concepts that we already understand and know, and dig in a little deeper. So I hope you learn a lot from this, and let's go ahead and get started. So what's a constant? Well, a constant is a value which is fixed and cannot be changed at any time during program execution. Well, that kind of makes sense, right? Because it's called a constant, so it has a constant value. To define a constant, we declare a variable, but prefix its type with the keyword const, C-O-N-S-T. And we'll get to some examples at the bottom of the screen. Now, we must initialize the variable at the time of declaration, and then it cannot change afterwards. Now you treat constants just like you treat regular variables, but again, its value cannot be modified after declaration. So you can see in the black box at the bottom of the screen, we use the keyword const, we define a string, and we name the variable game title. And at the time that we declare it, we also initialize it by assigning the value of the mantis to the game title variable, which is a string, but it's a constant string, which means that once we've declared this, it cannot change. Again, we declare another constant, which is of type string, and we call it game subtitle. And we assign a value to it, and that value is Bugman's return. Another reason why you might declare a constant is you might want to define the max number of players. So here we've defined that the max players is 4, and we've made that a constant. We don't want to have to redefine that multiple places throughout the application. The same thing is true with game title and game subtitle. We want it to be a constant value. Finally, another example of this would be we've declared an integer, made it constant, we've named it calendar months, and we've assigned a value of 12 to it. So the main thing to understand about a constant is it is simply a variable, but it cannot change after it's been initialized, and it must be initialized at the time of declaration. Okay, now let's kind of dig in a little bit into literals. So we've been using literals all along. A literal is an actual value that is expressly defined and used within a program. So anytime a value is directly assigned to a variable, that value is a literal. So for instance, we can see that we've declared a constant integer named calendar months and assigned a value of 12 to it. Because we assigned an actual literal value, that is known as a literal. It's the number 12. The same thing as we declared a constant integer and we named it weeks. We assigned a literal value of 52 to that variable. Once again, we declared a constant of type integer. We named it days, and we assigned a literal value of 365 to the days variable. Those were all examples of numeric constants. Now the same thing is true here. We declare a string. This is not a constant, but we just declare a string. and we name it name of month, and we assign to it the word January. Well, January is a literal value, so that is also a literal. Now, you can see that those are literal values that we've assigned. The next line does not use literals. So here we have declared a variable named days in week, and we've assigned to it days divided by weeks. Well, days is a variable divided by weeks, and weeks is a variable. There are no literals in that variable declaration or initialization statement. There are no literals there because we don't have an actual number that we're assigning, nor do we have a text inside of quotation marks that we're assigning. So in the above example, the number 12, 52, and 365 are literal values as they are expressly and literally defined. January is also a literal value as it is expressly and literally defined. Now, we've been using literals the whole time we've been programming so far. We just haven't known that they were called literals. So don't be confused by thinking that we're introducing some new concept. We're not. We're just letting you know the actual terms of concepts that you've already been using. January is also a literal value as it is expressly and literally defined. Now, days and weeks, as we discussed earlier, are not literal values, but rather they are variables. Now, most often, literals are used to assign initial values to variables. That's the most common use, but not always. You can also pass a literal to a function, but we'll get into that later on. Right now, let's just focus on the fact that we've been dealing with literals, and they are just simply expressly defined literal values that are used within the program. So let's look at numeric literals in more detail. So an integer literal is used to represent a numeric value as a whole number. A prefix and a suffix can be added to further help define the numeric type, but it's not required. It's important that you know it's not required. But you can use prefixes and suffixes in order to further denote the type of data that you want this numeric literal to represent. So a prefix in the form of a plus or a minus can be used to denote the sign of the integer. So is it positive or negative? Now this is a new concept that we're about to talk about, which is suffixes. A numeric value, you can append a suffix to the end of a literal and further define the type of numeric data that you would like for this value to represent. So if you assign a suffix of u, it can be used to denote an unsigned integer. An unsigned integer is a numeric whole number, right, that is always positive. It's not, you can't have a negative number because it's unsigned. A suffix of lowercase or uppercase l can be used to denote a long integer. And so a long integer it holds a larger value than a standard int 32. It's also you can also define it as simply a long, and it'll store a number that's roughly 2.1 billion. And then if no suffix is used at all, you just provide a numeric value for an integer, it by default is an int, right? Which is what we've been using. So if you don't provide a suffix, it is an integer by default. Now you may ask yourself, why in the world would I even want to use these suffixes? Well, you don't have to. They're not required. But in certain instances, you may want to force a numeric value into a particular data type. If you want to do that, then you have control. And the way that you do that is by using a numeric literal and then applying a suffix to the actual numeric value. Okay. So those were integers. Now let's look at numeric literal floating points. So a floating point literal represents numeric values that contain a decimal point and therefore are fractional. So a prefix and a suffix can be added to further help define the numeric type, but again, it's not always required. Now a prefix in the form of a plus or minus can be used to denote the sign of the numeric value, just like with integers, so you could define a positive or negative value. Typically, people don't use the plus. You know, by default, it is positive. You'll really only see the negative sign being used for the most part. But just know that you can use a positive sign if you'd like as a prefix. Finally, as a suffix, you can use a suffix of lowercase f or uppercase f to denote that the numeric value is a float. And floats are the largest. They denote the largest numeric value in C# and have the most granular precision from a decimal point perspective. So floats are very large and they use a lot of memory. So if you need a very, very accurate value, a float is the way to go. Now the standard suffix that's used is a lowercase d or uppercase d, and it's used to denote a double type value. And so again, these are all decimal points, decimal point values or floating point values. So if you use a d, it will tell the C# compiler that, hey, treat this numeric literal as a double. Finally, you can use an m, lowercase or uppercase, as a suffix, and it can be used to denote a decimal type value. And so, and it's just a standard decimal value. It's typically they're a little bit smaller than a double, but again, if you wanted to use a decimal or force a value type into a decimal, you could certainly do so. Now, if you do not use a suffix at all, the value will be treated as a double. And just to show you, if we look at the black box down below, here's a couple of examples. Like we declared a variable of type double, we called it accurate rating, and we assigned to it a value of 3.5 D. D just simply says, hey, treat this literal value as a double. The good thing is that we've defined the data type as a double, so it accepts 3.5 D without a problem. We've also got an example here of declaring a float. We call it a precise value. And then we've assigned to it a literal value of 1.0819 F. And because we put a suffix of F on there, it simply defines this literal value as a float. Finally, we've got decimal, and we're going to define it as cost of goods. A lot of times decimal is used to represent monetary values. And so we use the suffix of M, and we assign a literal value of 321.87. And then we put the suffix of M on there in order to define this as a literal decimal. Again, it's not necessary that you use these literal suffixes, but it does further help define the data. So it makes sense here because you can see that the precise example, we'll use precise value. You can see that precise value is a float. But what if we declared precise value at the top of our code file and we didn't assign a value to it? until the bottom of a code file, and you couldn't see that it was of type float anymore. At that point in time, you may want to use a suffix to help the programmer understand, or remind yourself that this value is of type float. And then the last example here is that we've done something incorrectly on purpose in order to make a point. We've declared a variable called wrong value of type float, and we've assigned to it a numeric literal of 199.87. But because we put a lowercase d suffix on the end, what we've done is we have defined this literal value as a double. Well, since we've defined it as a double, we're actually trying to assign it to a variable that's of type float. Won't allow us to do that. And that's why you see the red squiggly lines underneath of that numeric literal. It's because it's the wrong, we're trying to force it to be the wrong data type. If we were to simply take that D off of there, it would work. Or if we were to change that D to an F, it would work. And if you don't use a suffix at all, the default is a double. Okay, so let's move forward. Text literals. So there's a couple of different types of text literals. And the first one we're going to focus on is character. A character literal is a single Unicode character typically enclosed between single quotes, and it represents a single character. An example of a character literal is a single letter, such as the letter A, and we put single quotes around it. So single quotes around a single character represent a character. Double quotes represent a string. Now, a character literal can also represent an escape character, which in C# is a backslash. So, certain characters have a special meaning when they are preceded by a backslash. So a backslash is what we refer to as an escape character, and then the character following the backslash has a special meaning. So what if you wanted to actually print a backslash to the screen? Well, you couldn't just put a single backslash inside of a string. You would have to put a backslash, which is an escape character, followed by another backslash, and then that would produce the backslash character. A backslash apostrophe would actually print an apostrophe, because you couldn't actually just use an apostrophe, because then it would treat it as a character, right? But you could escape the apostrophe by using the backslash. Also, what if you wanted to print an actual quotation mark? Well, if you wanted a quotation mark to show up in your string, but not be considered to be, or to denote the beginning or end of the string, you could use an escape sequence. And here we use backslash quotation mark, and it would produce a quote character. Backslash question mark produces a question mark character. Backslash A will produce an alert or a bell. Backslash B will produce a backspace. Backslash F will produce form feed. Backslash N will produce a new line. Backslash R will produce a carriage return. Backslash T, a horizontal tab. Backslash V will produce a vertical tab. And then backslash X, followed by a hexadecimal code, will produce a hexadecimal number. Okay. So those are known as escape sequences, and they can be used within a string. So let's look at text literal strings. A string literal is a set of characters enclosed between double quotes. Remember, I told you a character literal is between single quotes, and a string literal is between double quotes. A string literal can contain characters or escape sequences. And that's good, right? Because we can use escape sequences inside of an actual string in order to get a certain value or result. Now, there's one exception to this. If you initialize a literal string with an at prefix, it is known as a verbatim string. Escape sequences will not work in a verbatim string. So let's look at the examples here in the black box at the bottom of your screen. You can see we've declared a variable of type string. We've named it name, and we've assigned to it the value of Trisonius. Trisonius is a literal value being assigned to the name variable. The next example is we've declared a string, and we've named the variable tab example. We've assigned to it a literal string with the words hello \t world. Now \t is an escape sequence that produces a tab, a horizontal tab. So hello \t world is a literal value containing an escape sequence of \t, which will produce the following result: hello tab world. The next example, we've declared another string variable. We've named it count, and we've assigned to it the value, the literal string value 1 \r\n 2 \r\n. Now that's a literal value containing escape sequences of \r and \n, which will produce a carriage return and a new line. So what that'll do is that'll result in 1 being printed to the console window, then moving to the new line and moving to the beginning of that line with a carriage return, and then it would produce the word 2 or the string 2 to the console window. So that \r \n actually ends the line and then moves to the beginning of the next line. Finally, we have declared our final string, and we've named it verbatim. And you've noticed that we've assigned to it a literal string which contains the words print space \a. Now, it's prefixed, though, with the @ symbol. So as a result, this is a verbatim string, which means that escape characters don't work. So this is actually going to print the word print with a space and print \a. It will not actually treat that \ as an escape character because it's a verbatim string. Okay. Now, is it necessary to know any of what I just told you about these literals? No, you can program without using these text literals, but these text literals do come in handy. Okay, let's go ahead and open up Visual Studio. So we're going to open up Visual Studio 2017, and we're going to go create a new project. So let's create a new console application project. And let's call this constant and literals. You can call it whatever you want. Name it whatever you want. Just make sure it's a console application using the .NET framework. Okay, so here's our new application. So what I want to do is, if I come in here, I want to declare a variable of type string that's going to be constant. And we'll call this title. So here, I'm going to type in const, and that's the keyword for a constant. Then other than that, we make it just like a regular variable declaration. So string, and we'll call this title. But remember, because it's a constant, we want to assign it or initialize it with a value, and then it can't change after that. So let's call this constants and literals. How about that? Okay. And here we can console.writeLine, and we can, let's write a blank line, and then console.writeLine, and let's write the title out, which should write out that value that we just put in there, right? And so if we come up here to debug and we start without debugging, we should see constants and literals show up in a console window. And there we go, constants and literals. It shows up, and then we get our press any key to continue because we started this using debug start without debugging. But you can see it's just like any other variable of type string that we've used so far. We are assigning this literal to this variable. This just happens to be a constant. So that makes sense. So what happens if we, right here, we decide to change title to something else? So title equals, this is an invalid change. And we put our semicolon at the end, right? You notice that we got a red squiggly line, and which typically is indicative of an error in Visual Studio. Well, why is that? Well, it's because we've defined this as a constant. Now we're trying to assign a value to it after it's been initialized. It's not going to let us change that. It's just not. Because it's a constant, we can't change its value. And so if we were to try to run this, it's going to say, oh, you know what, there were build errors. And so it just won't let us do it. And that's because we defined it as a constant. And that's what we want, right? The whole reason we use the const keyword is so that we protect that value and don't allow it to be changed. So that's good. So that's the use of a constant. And again, here's a literal string that we're assigning to that. Now, we could change this. What if we put a /r/n here, and then we put a /r/n here. Now these are escape sequences, right, that we're going to use inside of the string. /r means carriage return, /n means new line. So what happens now whenever we, by the way, I'm going to copy this and put it after this so that we have a blank line after we print as well. Okay, so what happens whenever we display title now? What does the addition of this escape sequence actually do? Well, start without debugging, and you can see that constants and literals. So it goes down to the next line. So you can see that /r/n after constants forces it to the next line. Then we have a space, the word and, a space, the word literals, and then it forces us to go to the next line again because of this. And so these escaped sequences embedded within the string actually get executed in order to, remember, they have special meaning after the backslash. So let's go ahead and end that application. Now what happens if we just put a single backslash in here? We get rid of this. Oh, look, it looks like we've got an error. The reason we have an error is because, remember, a backslash is an escape character. So it needs to be followed by one of those special characters. We're not following it by anything but a space. And so this is illegal. But if we wanted to print actual backslash, then we could put a double backslash, and then it will actually print a backslash. Okay, so let me put a space here. And just to show you, if we ran that, it's going to say constants backslash and literals. So there you go. printed a backslash. What if we changed this to backslash quotation mark? That means it's going to actually print a quotation mark. Let's see. Constants, quotation mark, and literals. So what if we wanted and literals to be surrounded by quotation marks? We could put backslash quotation mark here that will print it'll print a quotation mark. We have backslash quotation mark here that will print a quotation mark. And then we've got our beginning and ending quotation mark that represents this as a string, a literal string. So if we run this now, you'll see that constants and literals. We printed and literals within quotation marks. Okay. What if we just put /t here? Got rid of the backslash. And then ran this together and put /t. What /t does, if you remember, is it creates a tab. So it's going to print out the word constants, a tab, the word and, a tab, and the word literals. Let's see what it looks like. Constants and literals. So there you go. So let's get rid of the tabs. What if we put a \b here? That would be a backspace, right? So what happens when we run that? Oh, look. It did a backspace, and now it backed the word literals up against the word and, which is exactly what you would expect it to do. So you can see how to use these escape sequences. You know, I encourage you to play around with them, and they can be very, very valuable. So let's do a quick example with some numeric literals. So let's say that I declare a float, and let's name it precision, and make it equal to 3.1892 semicolon. Now this float named precision is being assigned a value, right? But why is this red? Why is it red? Remember, if we put a decimal point, by default, it's a double. Remember? So here we're trying to assign a double into a float. In fact, if we look at the error message down here, it says literal of type double cannot be implicitly converted to type float. Use an F suffix to create a literal of this type. It's telling you exactly what to do. So if I put an F here, well then suddenly it allows that, because now it's a float. I hope that makes sense. So in this particular example, we really did need to use the suffix. In most cases, you do not. But in this case, we did. Okay. Couple of things, other things that I want to show you that I have not shown you yet. When you're dealing with right line, you can use what's called a substitution method. I'll show you what I mean. We could put a literal string in here called, here's the title, okay, colon, and then we put these brackets and the number 0. And what that does is it signifies, hey, I want you to replace bracket 0 with the very first variable that I'm going to list. So we put a comma and we put the variable. So in this case, we're going to use the variable title. what's going to happen is it's going to print, here's the title, and it's going to replace bracket 0 with title. Okay, so let's see if that worked or not. Debug, start without debugging, and here's the title, constants and literals. See how it replaced here? This is called a string token, and we were able to substitute that token with an actual value contained within a variable. You can string as many of these tokens together as you like, but they start with the number 0. So let's say that we wanted to also follow it up with the next value. So, and the next value, we put a comma, and let's put precision. Okay. So what's going to happen, you start with 0, so it takes the first value, replaces 0 token, and it takes the second value and replaces 1 token. If you had a third value, you'd use a token and put a 2 inside of it. And so these go directly inside the string. So there's no reason to have to do string concatenation, so you don't have to use the plus. You don't have to try to figure out where your quotation mark should end, where it should begin. You can just put these tokens inside here, and then based on the numeric value, it represents the position of variable that it should be replaced by. So here, let's go ahead and run this as well. And you'll notice that here we've got, here's the title, constants and literals, and then so the title gets put here, and then this gets replaced by the second variable, which is precision. Okay, hope that makes sense. We haven't really used this, but this is pretty common, and it's a pretty good way to structure your strings in most cases, because it allows for substitution instead of you having to try to concatenate strings with a plus. Either way will work, so don't feel like you have to do one over the other. Everything that I'm showing you in this lesson is pretty much optional, but there's some I'm just digging in deeper to show you some different ways of doing things. Okay, well, I hope that you found this somewhat useful. I know this was a quick lesson, but it was a lesson that expanded upon the knowledge that you already had, and now you have a little bit more information than what you had before. I hope you find a use for this, and I hope you learned something today. So, I will be moving to the wrap-up here in just a moment. I appreciate your time. Thank you. Okay, so what did we learn today? Well, we learned that a constant is a value which is fixed and cannot be changed at any time during program execution. And we did an example of that, and you got to see the red line in Visual Studio indicating an error whenever we tried to change that value. A literal is just an actual value that is expressly defined and used within the program. So anytime we define a string inside of quotation marks or assign a numeric value directly to a variable, we're using literals. An integer literal is used to represent a numeric value as a whole number. A floating point literal represents a numeric value that contains a decimal point. A prefix and suffix can be added to further help define the numeric type, but it's not required in most cases. We did see one example where it was required, and that was when we were trying to assign a value to a float, because the default numeric decimal floating point value is a type double. A character literal is a single Unicode character typically enclosed between single quotes. A character literal can also represent an escape character, which is a backslash in C#, and we saw some examples of that. Certain characters have special meaning as part of an escape sequence, such as \r, \n, which is carriage return, or new line. \t would be a tab. \B would be backspace. And then also, if you initialize a literal string value with an @ prefix, it's known as a verbatim string. And verbatim strings do not allow for escape characters. They will literally print to the screen what you type verbatim. Okay, I hope you learned some. Again, there is no homework for this particular assignment. And so, until next time, this is Trisonius signing off.